Hi everyone, in today's lesson we are looking at Chapter 6, Section 3, Proving Quadrilaterals are Parallelograms. Our objectives are to prove that a quadrilateral is a parallelogram and to use coordinate geometry with parallelograms. Our standards are GCO 11. We start by looking at some theorems. Theorem 6.6. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. What this is saying is that if we are given sides of a quadrilateral and we know that both pairs of the sides are congruent, so looking at this picture, we can see that AD is congruent to CB and DC is congruent to BA, so we can say that this quadrilateral is a parallelogram. Theorem 6.7, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Again, same idea. If I look at the opposite pairs in this quadrilateral, I can see this angle A and angle C are congruent. I can also see that angle B and angle D are congruent. So opposite angles are congruent in this quadrilateral. So this is a parallelogram. Theorem 6.8. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. Looking at angle D has the same measure as angle B. Angle D's consecutive angle is A. Angle B's consecutive angle is A. Notice that angle A is supplementary. It's 180 minus X. If you have two consecutive angles and they are supplementary, then it is a parallelogram. Theorem 6.9. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. If we look inside this quadrilateral, we have diagonals DB and we have diagonal AC cutting this diagonal DB. Notice that in the intersection that the diagonals do bisect each other, creating two equal congruent line segments. So we can see that DM is congruent to BM and AM is congruent to CM. So we can say that this quadrilateral is a parallelogram. Example 1, proof of theorem 6.8. We are looking to prove theorem 6.8 and we are given that angle J is supplementary to angle K and angle M. We are to prove that JKLM is a parallelogram. So I'm going to start by marking angle J. And I know that angle K and angle M are supplementary to angle J. So if angle J is X, then angle K is going to be 180 degrees minus X. And angle M is going to be 180 degrees minus X. I know from chapter 3, section 4, we learned about a theorem called the consecutive interior angles converse, which says that if two lines are cut by a transversal so that consecutive interior angles are supplementary, then the lines are parallel. So if I have consecutive interior angles that are supplementary, in this case we're looking at angle J is congruent to angle K, that's what we're given, then we can say that line segment JM is parallel to line segment KL using the consecutive interior angles converse. And then knowing that angle J is supplementary to angle M, which is what we're given, then we can say that using the consecutive interior angle converse, that line segment JK is parallel to line segment ML. Since we have opposite pairs of line segments that are parallel to each other, using the definition of a parallelogram, we can say that JKLM is a parallelogram. All right, checkpoint problem number 1 is yours. In this problem, we have a stained glass, and we are told that a pane in a stained glass window has the shape shown at the right. How do you know that the pane is a parallelogram? Theorem 6.10. If one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So if we are given that one pair of opposite sides are congruent, so angle D and angle B are congruent, and that their opposite sides are congruent, then we can say that the quadrilateral is a parallelogram. Using properties of parallelogram, we are asked to show that point A located at 1 and 3, point B located at 3 and 5, point C located at 9 and 1, and point D located at 7 and -1 are the vertices of a parallelogram. There's 3 different ways that you can show that this quadrilateral is a parallelogram. We start by looking at method 1, in which we show that the opposite sides of the quadrilateral have the same slope. Remember, to find the slope of any line segment, it's y2 minus y1 over x2 minus x1. So let's start by looking at the slope of AB. We've got 5 minus 3 over 3 minus 1, which when you simplify that, you get 1. The opposite side for AB is CD, so let's look for the slope over there. We've got 1 minus a -1 over 9 minus 7, which this simplifies down to 1. So we can say that AB and CD have the same slope. Now let's look for the slope of BC. BC is 5 minus 1 over 3 minus 9, which gives me a -2/3. And the slope of AD is 3 minus a -1 over 1 minus 7, which also gives me a slope of 2/3. So BC and AD have the same slope and they're opposite for each other. Since we know that AB and CD have the same slope, they are parallel. Similarly, BC and AD are parallel too. Because opposite sides are parallel, ABCD is a parallelogram. Let's look at method 2. In this method, we are to show that the opposite sides have the same length. Remember, to find the length, we're using the distance formula over here, which is square root of x2 minus x1 square plus y2 minus y1 square. So let's start by looking at the distance of AB. Here we have 3 minus 1, the whole thing square, plus 5 minus 3, the whole thing square, which when you simplify this gives you the square root of 8, which in simplest form is 2 square root 2. Looking at line segment BC, take the square root of 9 minus 3 square plus 1 minus 5 square, and that gives you the square root of 52, which simplified gives you 2 square root of 13. CD, this is the square root of 9 minus 7 square plus 1 minus -1 square, which gives you the square root of 8, which simplifies down to 2 square root of 2. Finally, we've got AD. Take the square root of 7 minus 1 square plus -1 minus 3 square, which simplifies down to square root of 52, and that in its simplest form is 2 square root of 13. Notice in these lengths that AB and CD have the same length measurement, which we can see that AB and CD are opposite from each other. We also can see that BC and AD have the same measurement, and you can see over here that AD and BC are opposite from each other. So we can say that line segment AB is congruent to line segment CD, and line segment BC is congruent to line segment AD. Because both pairs of opposite sides are congruent, ABCD is a parallelogram. Finally, method 3. In method 3, we show that one pair of opposite sides is congruent and parallel. Using our values from method 1, we know that the slope of AB is equal to the slope of CD, which is 1. Using our values from method 2, we know that AB is equal to CD, which is 2 square root of 2. So knowing this, we can say that line segment AB and line segment CD are congruent and parallel, so ABCD is a parallelogram. All right, that's it from me. I'll see you all soon.